Students, welcome back to my channel once again. So today we will be discussing the CBSE board grade 9. The chapter is quadrilateral. So this is the part 4 video. Already I have discussed with 3 videos that are given as part 1, part 2 and part 3. So in the previous videos, we have discussed what is quadrilateral and the different types of quadrilaterals, right? And their properties, and also we have done some problems, and we did the midpoint theorem, and also we just applying the midpoint theorem, we have solved some problems. Okay, so let's take a look in this video. Uh, we will be solving more problems using the midpoint theorem, and also we will apply the different properties of the quadrilaterals. So let's dive into it. So the first question states that show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Okay, so let us take a look at the question. Let us understand the question first, then only we will go with the proof. So the quadrilateral is given, that is ABCD. Okay, now in the statement, look at the different key points, that is midpoints of the opposite side. Okay, so midpoints of the opposite sides means like the opposite side means AB and CD. These are the opposite sides, right? They are midpoints. So the midpoint of AB is P and midpoint of CD is R. Now similarly, so we can say that since it is the midpoint, so that means R DR. DR is equal to CR because it equally divides the line. Now similarly AP is equal to BP. Okay. Now let's take the other two opposite sides, that is AD and BC. So the midpoints of AD is S and midpoint of BC is Q here. Okay. Similarly, we can say that A is equal to DS and CQ equal to QB. Okay. So now what we need to prove over here. So first we got the midpoints. Now the line segment joining the midpoints. So now we have to join the midpoints like S and Q, we have to join, and similarly we will join P and R. Okay, so let's join these lines. Clear? So this diagram here, it is not given in the question, so you have to draw it and you have to understand the question and draw the diagram accordingly. Okay, then what we need to prove, that they bisect each other. So bisect each other means OS equal to OQ because they intersect at point O. So OS equal to OQ and OP equal to OR. Okay, that we need to prove. So that is written in the proof to prove. Now let's come to the actual proof part. So before we go ahead with the proof, we have to do some construction over here. So let us join the points PQRS. So it will form a quadrilateral. So let us draw PQRS quadrilateral. Okay. So for PQRS, PR and QS, these are the diagonals, right? So now we have to prove the diagonals bisect each other. So in this quadrilateral, if we can prove that the diagonals bisect each other, then our actual whatever is given in the question, that will be proved. So for that, prove that we know that diagonals bisect for a quadrilateral. When the diagonals bisect each other, that means the quadrilateral will be a parallelogram. So we need to prove over here that PQRS is a parallelogram. So now draw segment AC. Okay. So now we have to divide the quadrilateral into two. We know that whenever a diagonal, it basically divides a quadrilateral into two different triangles. So consider the triangle ABC. Okay, it is highlighted. P and Q are the midpoints of AB and BC respectively, right? So by midpoint theorem, we can say that PQ is parallel to AC and also PQ is half of AC. Okay. Now, in triangle ABC, P and Q are the midpoints of AB and BC respectively. So, we will just write that statement. So, PQ is parallel to AC. That is equation number 1. And PQ is also half of AC. So, that is equation number 2. Okay. So, we have to write also why we have written this statement by using the midpoint theorem. Now consider triangle ABC. So it is highlighted. So H and R are midpoints of AD and DC respectively. So by midpoint theorem, SR is parallel to AC and also SR is equal to half of AC. So we will also write that. So in triangle ADC, S and R are the midpoints of AD and DC respectively. So SR is parallel to AC and this is equation number 3. SR is half of AC. This is equation number 4. So by which theorem? That is the midpoint theorem. We can say that. Okay. Now these are the 4 equation or 4 criteria we have got. Okay. Now let's take equation number 1 and 3. So PQ is parallel to AC and SR is parallel to AC. So since AC is common over here, so we can clearly say that PQ is parallel to SR, because if we know that if a line is parallel to a line, then if two lines are parallel to a particular line, then these two lines will be parallel to each other, right? So I think this you have already learned in Euclid's geometry also. So now PQ is equal to half of AC and SR is also equal to half of AC. So we can say that PQ is equal to SR. Correct? Now we can see that PQ is parallel to SR and also PQ is equal to SR. So that means these are the opposite sides of a quadrilateral. So we know that whenever a quadrilateral have the opposite sides parallel and also equal, then we can say that the quadrilateral is a parallelogram. So hence we can prove that PQRS is a parallelogram. So we have to also write that why we are stating why it is a parallelogram. That a quadrilateral is a parallelogram if a pair of opposite sides is parallel and equal. Correct? So, and we know by using the properties of parallelogram, we know that the diagonals of a parallelogram, they bisect each other. So in this case, diagonals PR and QS of a parallelogram PQRS, it will bisect each other. So OP equal to OR and OQ equal to OS. So that's the they're asking. So thus we can say that the line segments joining the midpoints of opposite sides of quadrilateral bisect each other. So this whatever the statement is given, it is proved. Okay, hope it is clear to you. Okay, let's solve the next problem. In the figure, point X is the midpoint of side BC. Okay, let's see the figure over here. So in the figure, point X is the midpoint of side BC. Segment XZ is drawn parallel to side AB. So segment YZ is parallel to segment AX. Prove that YC is equal to 1 by 4th of BC. Okay, so what is given? That X is the midpoint of side BC. Okay, so this is the X is the midpoint, so that means BX equal to XC. Correct? So it equally divides. Now next statement states that segment XZ is drawn parallel to side AB. So XZ is parallel to AB. Okay? And segment YZ is parallel to AX. Okay, so these two are parallel. So we have to prove that YC. Let's check what is YC. So YC is 1 by 4th of BC. Okay, so YC is 1 by 4th of BC. Okay, now how we are going to prove it? So let's consider the triangle ABC. Okay, X is the midpoint of BC and XZ is parallel to AB. Correct? So we can say that by using the converse midpoint theorem, we can say that Z is the midpoint of AC. Okay. So in midpoint, what it says that if the two sides have the midpoints, if we join the midpoints, then the line segment will be parallel to each other and it will be the half of the third one. Correct? Like if XZ will be parallel to AB and also XZ will be half of AB. But and in converse midpoint theorem, if we draw a line segment that is through the midpoint of one side and it is parallel to the third side, then it will also be the midpoint of the other side. That is the converse midpoint theorem. So accordingly, Z will be the midpoint of AC over here. Correct. Now, whatever we have understood from this, now we have to write it. Okay. Now in triangle ABC, X is the midpoint of BC and XZ is parallel to AB. Okay, so this is given. So Z is the midpoint of AC by using the converse midpoint theorem. So always write, whenever you are solving anything, you have to write why you are stating that Z is the midpoint of AC. So write that, okay, by using the converse midpoint theorem. Now consider triangle AXC. Okay, this one. So Z is the midpoint of AC, that already we got. And it is given that ZY is parallel to AX. Okay. So what we can say that by using the converse midpoint theorem, Y will become now the midpoint of XC. So let us write this. In triangle AXC, Z is the midpoint of AC and ZY is parallel to AX. This is given. So Y will be the midpoint of XC by using converse of midpoint theorem. Okay. Now we need to prove that YC is 1 by 4th of BC. So what we got, Y is the midpoint of XC. So that means YC is equal to half of XC. Correct? Now, what is XC? XC is basically half of BC. So just replace that. Now let us write XC in terms of BC. So as already we know that X is the midpoint of BC. So XC is equal to half of BC. So half into half of BC means 1 by 4th of BC. So that's why YC is equal to 1 by 4th of BC. Hence it is proved. Okay. Now let's take a look at the another problem. ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal, and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. Okay, let's see the figure. Show that F is the midpoint of BC. Okay, what is given over here? ABCD is a trapezium. In this trapezium, AB is parallel to DC and BD is a diagonal. Okay, and E is the midpoint of AD. Okay, that means it equally divides AD. So AE is equal to ED. A line is drawn through E to AB intersecting BC at F. Okay, so EF is parallel to AB and it intersects BC at point F. We have to prove that F is the midpoint of BC. Okay, so means it equally divides the line segment BC. Now let's take a look how to solve this. So let us draw diagonal DB intersecting EF at G. Okay, so already we know that DB is a diagonal. So let us consider that it intersects the point at EF at G. Okay, now let's come to the proof. Now consider triangle DAB, the highlighted one. E is the midpoint of AD and EG is parallel to AB. Okay. So, by using the converse of midpoint theorem, G is the midpoint of BD over here. Okay. So, we will just write it down. In triangle DAB, E is the midpoint of AD EG is parallel to AB. So this is given. So G is the midpoint of DB by using the converse of midpoint theorem. Okay, now EF is parallel to AB, that is already we know. So, and AB is also parallel to CD. So, this is given. These two things are already given. So, since AB is common between these two, so we can clearly say that EF will also be parallel to DC. Okay. So, now GF is GF. So, EF is parallel to DC means we can say that GF is also parallel to DC. Correct. Now, consider the triangle BCD. It is highlighted one. Okay. Now, G is the midpoint of BD and GF is parallel to DC. So, this is already we have proved, like G is the midpoint and GF is parallel to DC. Correct. So, now by converse of midpoint theorem, what will we can say that F will be the midpoint of BC. So, let us write it down. In triangle BDC, G is the midpoint of DB and GF is parallel to DC. So, F is the midpoint of BC by converse of midpoint theorem. So, that's what they are asking to prove, that F will be the midpoint of BC. So, that's already we proved it. Okay, so now let's move to the next problem. PQRS is a parallelogram in which A is the midpoint of side SR and point B is the point on diagonal PR such that RB equal to 1 by 4th of PR. Also, AB when produced meets skewer at C, prove that point C is the midpoint of side QR. Okay, you know that you couldn't understand. So let us draw it first. So PQRS is the parallelogram, right? Now A is the midpoint of side SR. So let's check which one. Okay. So that means AS is equal to AR since A is the midpoint and B is the point on diagonal PR. So let's check the PR and B is the point on diagonal PR such that RB is equal to 1 by 4th of PR. Okay. Now we need to prove that point C. Let us check point C is the midpoint of side QR. Okay. So what is point C? Point C is basically when AB is produced, it meets QR at C. So now C is the midpoint of side QR that we need to prove. So let us consider triangle RSQ. Okay, the highlighted one. So in RSQ triangle, A is the midpoint of SR. Okay. Now we just have to prove that AC is parallel to SQ. If we can prove that, then we can apply the converse midpoint theorem and we can prove that C will be the midpoint of RQ. Now let's take a look. So by converse of midpoint theorem, we will get C as midpoint of QR. That's what I already said. Okay. Now the hint is given that we have to prove that AC is parallel to SQ. Now let's take a note, like see how we are going to prove AC is parallel to SQ. So let us use the given information. What is given over here? That RB is equal to 1 by 4th of PR. Okay. So let us write it. Now PQR is a parallelogram that is given. So we know that by using the parallelogram properties, we know that diagonals are parallelogram, they bisect each other. So that means the parallelogram by diagonals are PR and SQ. They meet at point O and they also bisect each other. So that means SO is equal to OQ and OP is equal to OR. So PR. So let us take PR. So that since it is bisect, so PR will be double of 2 into OR. Correct. Now, so RB we can say that is 1 by 4 into 2R to OR. So that means that is half of OR. So RB is basically half of OR means B is the midpoint of OR. Correct? So B is the midpoint of segment OR. Now let us consider the triangle RSO. Okay. So in triangle RSO, A and B are the midpoints of SR and OR respectively. So and AB is parallel to SO. Okay. So these A and B are the midpoints of SR and OR respectively. So we can say that by using the midpoint theorem, AB is parallel to SO. Correct? So AB is parallel to SO means AC is also parallel to SQ because these are the extended lines. Na? So now consider triangle RSQ. Okay, the highlighted one. So in triangle RSQ, A is the midpoint of segment RS and AC is parallel to AQ. So hence we can say that C is the midpoint of side QR by using the converse of midpoint theorem. Clear? Okay, so that's all for today. I hope you have understood all the problems properly. If you have any doubt, then you can put it in the comment section. And if you like my video, please hit the like button. And also do share this with your friends so they can also learn from this video about the quadrilateral chapter. And please subscribe to my channel to get the notification of the future videos of quadrilaterals and other topics as well, the other chapters that are there in your CBSE class 9. So that I'll be covering up. So please subscribe to get the notification for the future videos that I'll be posting. Okay, that's all for today. And thanks. Bye bye.